Okay, I guess you can start from introduction. 1 minute.
If is it live, let me know.
Sure, it is live now. You can start from introduction.
Yes. Thank you, Navaneet, for giving me this opportunity. And yeah, we are we will have 3 to 4 session on the Docker series. So this will be our first series on Docker. Here we will cover all about the introduction to Docker, and next in the coming session we will go deep at the advance of the Docker here. So I hope everyone are doing great. And about myself, I'm doing my final year from Manna University MIT campus. I'm also doing my software developer internship from Cisco Technology. I'm into software development and DevOps from past 3 years. Going into the topic now, you guys all know Docker Inc. is an organization which has a tool called Docker, and we use the tool for the need of containerization here. So starting from the base, when I got introduced to the topic containerization, first why I got into containerization, I will first talk on that because containerization is a problem where everyone uh, go around. So here initially I was working on a project where we have to develop a programming website like this. So you guys, I know everyone are aware of Lead Code, Code Chef, and HackerRank and all. Here in the programming website, we have a Q&A on the left side, question on the left side, and on the right side, we have our code here. In the code, we can select which language we want. We want C++, Python, and all. Then we write our code. Then we submit our code, right? When we do submit, our code goes to the uh, backend server of Lead Code or which organization it is. It goes to their backend server and get compiles, right? You guys know, you guys have come across virus which copy paste a lot of folder and occupy your RAM, occupy your hard disk. Similarly, you can write some code which can occupy lot of RAM, lot of processor, and it can utilize all the system backend resources, and the server goes down. If you write that time, if you write that type of code where the backend server of Lead Code or the organization, their whole server will go down, right? If you write those code which could crash the server, then the whole backend server goes down, in the sense the all the other application which are running on the backend server also goes down. That means that organization go offline. So we need to tackle this solution, right? We have to compile your code into a safe environment where it gets affected and it doesn't affect the other services or other programs running on the site, right? So we need to solve this problem. So Docker company, Docker organization solve this problem using a technique called containerization here. So what happened here? So what is Docker? So Docker, it creates a container where container is the, you can call it as safe environment or a safe sandbox where all the required libraries, databases, service, and your code goes into that container. And when that container, for example, get crashed, only that container get crashed and a new container gets created. So that means the other services running by site won't get affected. Going into the detailed definition of Docker given by the organization. So Docker is an open platform for developing, shipping, and running application. In Docker, you can develop your application, you can ship your application, and obviously run your application. Second point, Docker enables you to separate your application from your infrastructure, so you can deliver software quickly. So this point, your Docker enable you to separate your application from your overall application running by side. So here, if one things get affected, the other things don't get affected here. Next, going to the third point, by taking advantage of Docker methodology of for shipping and testing and deploying code quickly, you can significantly reduce the delay between writing code and running it in production. So the point here, what it is, when we write a code on the development phase, sometimes it doesn't run on the production phase, right? So why? Because some of the libraries or some of the databases or some of the services which we have on our system, and if we don't install those libraries, those services on the production phase, obviously our application won't get run. But if we use Docker here, what happen? The container will have all the required libraries and all the required software to run that application will also get installed on that container. So when you ship that container to the production, obviously all the libraries and all the code will also go along with it. So your application will run also in the production. So here the difference of running in the production and in the development won't be different. It will be exactly same. Required the production server also has the required infrastructure like the hardware, RAM, which required the Docker to run. Cool. Next, isn't Docker is same as virtual machine? In the virtual machine, what we do, we install a new OS, and in the OS, we also specify what is the RAM that OS required. So similarly, the Docker also run on the methodology of virtual machine. In the virtual machine, what happens? We install a new operating system on an existing operating system, right? We install a different operating system like Windows 8 or Windows 10 or Linux, any Linux. We install a new operating system. When we install a new operating system, the drivers, the system 32, a new user, all these additional files which actually don't require you to run your application. These are just the additional files of an operating system which already exist on your host operating system, right? So if you put an virtual machine, the application will also be heavyweight, right? The some of operating system like Windows take at least 4 GB, 2 GB of RAM to just to run the operating system, right? So virtual machine is an heavyweight application if you go with the virtual machine. But if you come in the side of container, what here happens is you don't actually install a new operating system. You use your existing operating system, and on top of operating system, you have something called Docker engine. Container engine. So here Docker provide a container engine called Docker daemon. Now this Docker daemon is your container engine, and it connects the gap between an operating system and your application for running that application. So here basically you don't actually install additional operating systems here. You use the existing operating system, so it is very lightweight here. So your container will actually have very less space when compared to when you compare with a virtual machine. Also, one point, when you actually open a virtual machine, it around takes 1 minute, 2 minutes, 3 minutes to boot up, right? But here in terms of container, you don't actually boot up. Your operating system is already booted up, so it only takes 2 to 3 seconds just to run your application. Okay, so here if we see overall, your container takes very less time and lightweight. On simple note, virtual machine is just like building your own house. Now here your house is the operating system, a new operating system on an existing operating system. If you see container, you have a building. Now this building is the container engine, that is Docker daemon, and inside the building you have lot of rooms here, right? Now this rooms you can take it as a container, and on each room you can run your own application, different application. If something happens in one room, it won't be affected by other people's living in the other rooms. If we go in depth, let's see here. So now your operating system uses your computer hardware, right? Now your operating system will have a kernel, right? And your Docker engine, that is the Docker daemon, will use your operating system kernel to run all the containers here. So containerization run on a technique called virtualization. Now what virtualization is? Virtualization uses two main factors here, namespace and C groups. C groups means control groups. Here the namespace and C groups are used to distribute and limit your resources. In the sense, you will actually assign how much RAM or how much hardware is required to run a container. For example, 1 GB or one virtual CPU to run a container will be assigned by the namespace and C groups. So here the kernel will be same for all the containers here. So here if you make changes in one container kernel, it will also get affected in the another container kernel, right? So this problem is solved by the technique called containerization. Here in the containerization, you use a technique called Hyper-V isolation, where you actually separate all the container kernel with each of the containers. So if one kernel of one container get affected, it won't be affecting the other container kernel here. So you use Hyper-V here. Next, Docker is actually used by 98% of the enterprise solution here. So most of the famous companies like Uber, Spotify, Cloud Sound all use this Docker technology, and with the Docker technology, they also use additional technology, advanced technology like Kubernetes also. They use architecture technique called microservice here. Microservice in the sense, you actually use different containers to run different services, right? So most of the famous companies use this architecture to actually fasten and also to scale this application higher. How you can scale? If you have one container to run one application, you can run multiple containers to actually support multiple users. So you can actually easily scale this. We call this as horizontal scaling. Next, if we go into Docker architecture, let's start from the client side. Now, basically in the client side, you have your terminal, or you can also have your remote API where you can write the Docker code here. We will go into the Docker code in the next upcoming section. Next, you have the host. Host is nothing but your Docker, which is installed your system, or it is somewhere on the cloud. Here, the Docker engine is used to manage all the images and all the containers. Now, these container images, we will come upon it. Next, we have also have something called as registry. In the registry, we have something called Docker Hub. Now, we will come into the topic of Docker Hub in the next few minutes. Now, to start with the Docker, how we can start writing application is we will start writing our application with the Docker file. Now, what is Docker file? Docker file is a text file with instruction to build an image. So basically, Docker file is a text file which where we can write lot of instruction to actually create a Docker image. Now, what Docker image? Docker image is a template to create a container here. So basically a template, we can't directly edit the template, but we can copy the template and actually convert the template into a container. So here our Docker image is a read-only file, right? Next we have our Docker container. Now the Docker container is a running instance of Docker image. We use the Docker image to create a container, and in that container we can write our code, we can compile our code, we can basically run our application on the Docker container here. So Docker container is a read and write both, and Docker image is read only. So Docker Hub, it is very interesting. So listen, Docker Hub is a repository where you will find official Docker images and also customized Docker images. So basically, it is a repository. Repository just like GitHub, where in the GitHub you have the official open source code of VLC, Docker, Kubernetes, right? Similarly, you can also have your customized Docker images. Customized Docker images in the sense you can create your own application and put that Docker image into a Docker Hub. Just like you upload your code from your local repository to GitHub, right? It is similar. Now let's go into Docker Hub here. So if I go into Docker Hub, you can see we have the okay, we have the website called hub.docker.com. So here, when I search what I can search, I will search Python. So if you search Python, you can see there are a lot of images, extension, plugins. There are additional extension and plugins also in the Docker Hub. So you can see this Python is there, this PyPy, this Highland. This all are the official Docker images. You can see the tag, right? Docker official images. So if I go into that images, you can see this is a Python official images. So if I want to build a Python application, what I will do, I will use this Python Docker image, and in that image I will add my code and I will create my own image and run that image into a Docker container. Okay, so you can see there are some simple tags here. So what are tags? Tags are nothing but the version of the Docker images. So let's say you have a code which only runs on Python 3.9, and here we have Python 3.12. So I exactly need Python 3.1. Then what I will do, I will write something like this: Python, uh, Python semicolon and 3.10. If I just write Python, what it will do, it will take the latest image. Now, what is the latest image? If I go into the tag section here, so the latest image is this one, 3.12.obs ob3 hyphen slim bull eye. Now this slim bull eye is nothing but the operating system here. We can also have this Python in a Windows operating system. So if I go and search Windows, I will get the Python image which is installed on the Windows here. So you can see this is the Python version of 3.12 which is installed in a Windows server here. Cool. So Docker Hub overall, it is a repository where you can find the official images and also your own customized images. Next, actually, we will do hands-on experiment on Docker here. So first, initially, you don't have to actually install Docker desktop on your own system. What we can do is we can start using Docker with which is deployed in the cloud online. So I will write play with the Docker. So if you type play with the Docker, you will have the first website of Docker organization. So labs.play-with-docker.com. So initially you need a login password, right, to go and access this website. So in the login, you need the Docker registration here. So Docker registration in the sense, if you go into the Docker Hub, you have to create a you have to create your own account on the Docker Hub. You can simply go and create it by doing the register and writing your own username, email, and password, and you can create your Docker Hub account. Now that Docker Hub account is your Docker account. Now that Docker Hub account you can use to access this Play with the Docker website. Now when I click play, one session is created for me. So this session will last for around 4 hours. So right now I can do whatever I want with the Docker, like around 4 hours. So right now I will create a new instance here. So creating a new instance in the sense creating a new like operating system. You can see a new operating system where I have Docker installed. Now, if I want to see if my Docker is installed or not, I will type Docker -v. Now here Docker is our command where we use everywhere here. Now -v is the version. So if I type Docker V, I can see Docker version 24.0.2. So it is the latest version of Docker. So initially what I will do is, initially if you start with any programming language, what you will do, you will type hello world, right? Similarly in the Docker, you can do the same here. What I will type is, I will type hello world. So you can see this hello-world. It is an official Docker image. So it is an official Docker image where you can start using this. So I will use this to here to create my container. So this is a official Docker image which I will use to create a Docker container. How I will create? You will use a command called run. So Docker run hello-world. Okay, so starting from the start, unable to find image hello world hyphen latest semicolon latest locally. So if you just mention hello world, what it will do, it will take the latest image of that hello world. Now you can see it cannot find the hello world image locally. That means your image is not present in locally. It is not present in the local system. So what it will do, it will be pulling from library hyphen hello world. Here the library in the sense Docker Hub. Docker Hub is your repository, right, where all your official Docker images are present. So it will pull from the Docker Hub library and it will take the hello world image. So here you can see some of the few tags here. Digest. These are nothing but layers here. We will talk about layers in depth in the upcoming session here. Just to give you a rough idea, Docker image is built upon lot of layers here. So your Docker image is nothing but a component of lot of layers. So here basically this SHA-256 is one of the layer which is used to run this hello world image. So one layer is installed, downloaded in our local. Next we have the command hello from Docker. That means your image is run on your system. So right now your container is run using the hello world image and your output has been printed here hello from Docker. Now one question, is your Docker container right now running or it is exited? So in your system you use ls, right? Ls to see what are the files present. Similarly in Docker you have the command called docker ps. Now ps is used to see which are the active containers running right now. So if I use docker ps, I don't see any container. I just see the columns heading called container id images command creator. So I don't see the Docker container here. So that means our container got created, our output was printed, and the container automatically got destroyed. So if I want to see what are the containers is actually created, so I will do docker ps -a. So -a, you used to see hidden files, right? ls-a, you used to see hidden files. Similarly, you use ps-a to see what are the containers was created here. So if any container is created, a container ID is assigned here. So container ID is this one. Your container ID is v5f94. This is your container ID here. Then the image, what image you have used? You have used the hello-world image here. What is the command here? The command, actually we will see about the command in depth in the upcoming session, and you can also see created. This container was created 2 minutes ago. and you can see the status. Right now the status, it is actively running or not. It is not actively running. You can see it has been exited with a status code of 0, and it was exited 2 minutes ago. Now the ports, we will see about the ports in the next few minutes, and the names. Name in the sense the name of your Docker container here. So we haven't put any name on the Docker container here. So it was automatically created a random name. The random name it took was upbeat hyphen note 8 or something. So what we will do, we will assign a name here. So how we can assign a name? We will write Docker hyphen hyphen name. So this hyphen hyphen name space the name which you can type. I will type intro to Docker, and my image name is hello hyphen world. So basically I have written Docker hyphen hyphen name and the name of the Docker container which I want to put here, then the hello world image. Now when I type enter, what happens here? um, Okay. Okay, I haven't put the name run. So Docker run. So run command is used to actually convert your image into a container. So Docker run hyphen hyphen name. The name I want to put as intro to Docker. Then my image name hello hyphen world. So now we got the output hello from Docker. If you notice one thing here, we don't have the this thing called what, unable to find image locally. So basically we haven't received this message, right? That means the image was present locally, so it didn't actually go into Docker Hub and downloaded the image. It actually saw in the local, and in the local the hello image the hello world image was there. So it directly took that image and printed hello from Docker, now exited. So if we do Docker PS, no active containers are running. So if we do Docker PS -a, we can see the image which with the container which we recently created intro to Docker, and the name was this, which we actually mentioned. So overall, Docker PS is command is used to see which active images are running. And also, if you want to see what are the images which are actually downloaded locally, you can see using Docker images. So if you type Docker images, you can see you have the hello world image of tag in the sense the latest version of the hello world. You also have the image ID here. If you create a container, you will have a container name and you will have container ID. Similarly, you will have a hello world image of tag and image ID here, which was created 7 weeks ago. Created in the sense the official Docker Hub actually created this latest version of Docker hello world image 7 weeks ago, and the size of image is just 13.3 KB. Your size of this image is just 13.3 KB. Just to print this hello from world, it is as simple as 13.3 KB. Right. Next, we will go on with writing a SQL application here. So I am a big fan of MongoDB. So I don't generally work with SQL. So if I have a project right now where I want to actually use SQL, what I will do, I will go into SQL website and my PHP admin website, and I will download all the SQL software, right? But I want to just work on SQL for just 3 to 4 days, and I don't want to download SQL. So what I can do, I can use this Docker tool to actually just create a SQL container here. So if I just create a SQL container, I can use that container when it is active, and I can easily delete or stop that container to actually unstop the SQL software here. So I don't have to actually run the install the software, and I can, instead of installing all the software which are required, I can just use the SQL container here. So if I go into Docker Hub and I want to, right now I want to create a MySQL application, I will go and search MySQL. If I go into MySQL, I can see official Docker image is there of MySQL. So if I go into that, I can just use this MySQL application to set up a MySQL in my local. Instead of downloading MySQL and PHP MyAdmin, I can just go and have this. So in previously, what we do is we just put Docker run and our image name. Here SQL needs some additional commands here. You can see the additional commands here. Docker run hyphen name some MySQL. That means we are assigning a name to that container as some SQL. Then hyphen E, we have something here. Then hyphen D, then the MySQL semicolon tag. Okay, we will come into it right now. I guess you can see here. Yeah, this is our online terminal, and this is our command here. So I want to run docker run hyphen name. What I will put my name as just MySQL. The name of the container will be MySQL. Then something called hyphen e. Now this hyphen is nothing but the environment you use with the env, right? The .env file where you actually have the constant name and the value of that constant name here, my secret. Now why we have this in MySQL is because we actually have a password for the root user, right? If we are installing a software here, we obviously put some password on the root. So similarly here we actually mentioning the password as the constant name is MySQL underscore root underscore password equal to the password. What I will just put 123 as my password of the root. Then we have something called hyphen D. Now this hyphen D command is nothing but detached mode. Detached mode in the sense, let's try without hyphen D. You will better understand. And then I will type MySQL. Then we have semicolon tag. So I won't be using semicolon tag because I want the latest version of the MySQL. Then I will type enter. Here you can see I haven't put hyphen D here. Just see what happens if I don't put hyphen D and what if I put hyphen D. Let's see. So right now you can see unable to find image locally. So I don't have a local image of MySQL. So it goes into Docker Hub and actually extract that, not extract, we use a word called pull. So it actually pulled that image from Docker Hub into our local system. So you can see this, for this all are nothing but layers. So this MySQL is built upon all these layers here. We will talk about layers when we write our own customized Docker image in the upcoming session here. So you can see actually the Docker, the container MySQL is running here. But I want to go out of terminal. I don't want to stay here because it this all are the MySQL backend code here. All are coming in my terminal itself. I have to exit from this. So what I will do, I will write Control C. If I do Control C, what happens? The container actually get exited, right? With the exit code of 1. I will do exit here. So hyphen D is nothing but detached mode. Detached mode in the sense we don't actually enter into the MySQL container and we just spin up the container. Spin up in the sense, spin up is mostly used to actually create a container and run that container. So if I want to exit from this, if I do just Control C, the whole container will get crashed. So I just want to run that container and I don't want to enter the container. Then we use the keyword hyphen D. So I don't know, this is not working here. So I will create a new instance instead of just going into this. So I will run docker run. Then I will have a name called MySQL. Then I have to assign the environment name. So what is the environment if I see here? It is MySQL underscore root underscore password. MySQL underscore root underscore password. Then equal to this password is nothing but my SQL root password. So I will assign it as 123, and I will also do this 3306. Then my image name MySQL. So now you can see something like, oh, I haven't put my hyphen D. So I will also go in the detached mode here. So this command hyphen p is nothing but your port. So when you actually create a container, you actually want to talk to the container, right? If you want to talk to that container, what you have to do, you have to expose the port. For example, if you run your own applications, your application will run on localhost 3000 or localhost 80 or localhost 3030. Similarly, your SQL run on the port called 3306. If I want to talk to that SQL container, I have to actually expose the port. So this one is the 3306 is the exposing port of that container, and this is the exposed port of that container. We will talk about port in depth when we write our Docker file in the next upcoming session. So finding locally, because this one is different from this one, right? So you can see the whole backend code came here. So if here I have put actually -d, so I won't be actually going into all this backend code, and I will just spin up the container and I will be in my terminal itself instead of going inside the Docker container terminal, right? Just a few minutes, all the layers have been downloading from the Docker Hub here. Yes. So you can see I have been exited from this instead of going into inside that SQL command here, right? So right now, if I want to see if my this SQL container is running or not, what I can do, I will enter Docker PS. So Docker PS is used to see which are the active container running. So I can see my SQL is running actively right now. So you can see here created 18 seconds ago, on status is up in the sense it is running. And you can also see the ports here. Ports are nothing but the ports which are exposed here. So we can see this 3306 has been exposed. That means I can enter into this port and I can actually access the SQL here. So you will also see here this 3306 is being exposed here. And with this, this is the backend software of SQL being running here. I also want a graphical interface. Now, what is the graphical interface of SQL? We use basically PHP myadmin, right? We use PHP myadmin for the graphical interface, right? I won't be installing this PHP myadmin. Instead of installing this, I will also spin up another container to use this PHP myadmin. So if I go into PHP myadmin, I can see we have an official Docker image of PHP myadmin software here. So similarly, if I just scroll down, I can see a command here, docker and hyphen name. I can actually assign a name to that Docker container, and -d. I guess you guys have the idea of why we use -d here. And we have another command here, hyphen link. Link is nothing but linking your graphical interface with the backend database available. So we have SQL, right? So basically we will write the SQL semicolon db. Next we also have the port here. So we will actually run this here. So docker run. Next we will assign a name to this. This is my PHP admin. Then what we will do? We will we will do -d, that is detached mode. Then we will link our MySQL. So our container name was MySQL, right? So I will write my container name here. You can actually write your container name, or you can also write your container ID here. Both are same here. So I will write my container name and also semicolon db, because our this SQL is a database, right? So I will write db. If I spin up a MongoDB, I will write MongoDB semicolon db. So I wrote MySQL db. Then we have to expose the port. Expose in the sense to actually access this. So 8083 semicolon 8 80838. Then the image name is, what is the image name? PHP myadmin. PHP myadmin. Right. So if I enter, so it will actually see locally. So PHP myadmin is not there locally. So it will download the image from the repository, from the Docker Hub repository, and you can see this all are the layers here. We will talk about layers in depth, right? So right now all the required layers of that image is in downloading. Next, yes. So status downloaded newer image. So you can see the exposed port here. So 83 is the exposed port here. Hmm. So I can see the PHP my admin, right? This page is loading. So this is the what is this? This is the graphical interface of a MySQL database. So I will write the MySQL root user here. So I have created a root user with the password 123, right? So 123. Next I will do login. Tada, you have been logged into MySQL database here, right? So you can go and create a new database here. So what happen if I create a database? Those database will be stored inside the container of MySQL here, right? So I will just create a container called intro to Docker and create. So new database have been created. I can create the table, lot of label in MySQL, and I can access this table. So if I go in my local and I want to access this, then what I can do, I can access this using this link, right? Uh, Using this link. This IP address here. It is this IP is been exposed, right? So this IP address and the semicolon. I will do it. Okay. This IP address and the semicolon 83. We have exposed the port 83, right? So I can use this link to actually connect my local system with this online uploaded online link newly created my SQL database here, right? That's it. I guess we have talked about Docker introduction, Docker fundamentals like Docker images, Docker file, and Docker containers. Here we have also have like created the official, actually not created. We have actually run the official Docker images of Hello World, My PHP, and also SQL. Next, in the next upcoming session, we will also talk about customizing your own Docker image. I want to customize my own. I will create my own Python file where I will print Hello World, and I will create that as a Docker image. So, and I will also put the Docker image in Docker Hub, just like in GitHub, you put your own code into GitHub, right? So we will talk all about this in depth in the next upcoming session. If you guys have any doubt, you can.
Surinder, we have one question from Sakil. May I know the difference between image name and the hyphen name?
Image name and the hyphen name. So this one, my SQL semicolon latest is the official image name here. Okay, image name will be. I guess you are talking about this, right? This one repository is this MySQL is the image name in the which is present in the Docker Hub. If I type Docker PS, so you can see this image is the image used to create this container. So we have this MySQL, this MyPHP admin. These are the names of not the images, but these are the names of the Docker containers here, container name. If I write Docker PS hyphen A, so when we actually first created the hello world, when we actually first created a hello world, if we don't mention the name, a random name is assigned to the container here, not the image, the container here. And when I assign like hyphen name, when I use this hyphen name, I can actually customize the container name myself. If I put intro, this intro will be the customized name of the Docker container, which I will create with either my SQL image or my PHP image, right? Is it clear? Yes. Hmm. And yes, thank you guys. You can connect over me with LinkedIn here. You can scan this QR. And also, if you have any doubt, please mention in the comment section. And also, if you want any additional topic which I need to cover with the Docker, we will obviously cover the advanced topic in the next series. If you have any doubt related to Docker image container, you can ask in the comment section right now. Do we have any doubts, Navneet?
Yeah. The next question from Akshay. How will I
Hmm.
start multiple
Multiple.
containers using the same image? Also, how
Yeah,
will
good
I
question.
stop a container?
Yes, nice question. So, okay. So creating multiple containers here. So this topic here, multiple containers. This multiple containers are nothing but a microservice application. If I type microservice here on the Google, I can see an image of this. So monolith is nothing but a single application, but microservice in the sense multiple containers here. So if I want to create multiple containers here, then what I will do, there is another tool called Docker Compose, which we will discuss in our third or fourth series session, where we can create multiple containers just using one file. That file name will be Docker Compose .yaml file. It will be a YAML file where we can create multiple containers. And the next question was, how will I stop? So if I have to stop a container, so if you have any like such question law like related to Docker commands, just don't mug up all these commands. Just go into a new tab and write Docker stop a container. I usually don't actually remember all the command name. I will just type the what I need. I will try Docker stop the container name. So if I want to stop that, Docker stop what was that, Docker stop additional option. I don't want. I just write container and the container name. So right now which containers are running, if I you can only stop the active running containers, right? You can't stop existing exited container. So if I type Docker ps, you can see these two active containers here. These two active containers are running. So I will type Docker stop container, and you can see the name of the container, right? MySQL. So I will type MySQL. So if you get the output of the name of MySQL, you can see your container has been stopped. Error response from daemon, no such container. Okay, I will do Docker ps. So yeah, that container was exited. Now only my PHP admin container is running. I can also stop my container using the container ID. Instead of writing the name, I can also use the ID. You can see the ID here, right? So what I will do, I will write Docker stop container and the container ID. Container ID is C136B1B31565. So in the output, you will get the container ID. As a response, you will get a container ID, which means your container has been stopped. So if I type Docker ps, which is used to see which are the active containers running, no active containers are running, right? First, the SQL container was stopped with the Docker stop container MySQL, and this PHP has been stopped with the Docker stop container, the container ID here. And another interesting question, how we can run a same container multiple times. Like if I have a container of printing hello world, if I run that container and if I just, that container will just print hello world, and I want to like spin up 10 containers where I will get output of hello world 10 times. So I can either use Docker compose technique, which we will discuss in the third session of creating multiple containers. There you can just mention how many uh, replica you need. Replica in the sense the how many number of containers of same container type you need. If I that is used with the Docker compose. If I want to see only with the Docker, how I will see Docker spin up. Spin up is used to see used for running a container. Okay, so Docker spin up same containers n times. So I will just write this command. Is it possible to run a container multiple times? Hmm, not this. Uh, Docker run container 2 times. This one is a single. So I will type Docker run. Actually, replica is used for the same container running twice or thrice. So yeah, Docker service scale service equal to replica. Uh, hmm. So you can see Docker service scale front end. So here, what is the front end? Front end is the container name here. So let's try this. So what are the Docker images we have right now? So right now we have MySQL. So let's do this. Uh, Docker service VICE scale scale our MySQL equal to error response from this node is not a swarm. Okay, this one is the swarm. Basically, we can use the Docker Compose here instead of using this service. Actually, this service scale was used by Swarm here, but the Swarm is no longer supported with the Docker. So we will actually use a Docker Compose file to run multiple containers of same type here. Let me try this Docker run --name replica SQL. Then I will write replica to MySQL. So you can see replica is not there. Basically, yes, replicas are not there. Okay, replicas.
Surinder, it's fine. We can see that in next session.
So, yeah, that's what I thought. So replica is not there. You can use Docker Compose to run multiple containers here. So we will talk about running multiple containers with using Docker Compose in the next upcoming session.
Hey,
Any other
thank you,
doubts?
Surinder, for the wonderful session on the Docker containers as well as the Docker images part. So you have very well covered in terms of the hands-on also. So we are
Thank
waiting
you.
for your the next upcoming session. In another episode, we will host you. And thank you so much. And please stay tuned on the Microsoft Azure Developer Community Chennai for more updates on the online series. Thanks, everyone.
That's right. Thank you, guys.
Thank you all.